This video is sponsored by PCBWay.
Hey there, this is Seth Schaefer from Team Just Cause Robotics, and this is a lithium polymer battery. These are at the heart of the most competitive BattleBots and the most incredible power-dense electronics projects, and these are the secret to making your next combat robot or mobile robotics project as great as it can possibly be. If you respect these batteries, you can use them safely and easily to power any kind of project. But if not treated carefully, they can definitely burn your house down. Through following the tips that I'll give you in this video, you won't have to worry about that at all, because it's really not that hard to treat these with the care that they deserve and prevent them from ever catching fire, and they are by far and away the best way to power your next BattleBot. My goal with this video is to explain exactly what a LiPo battery is, what all of the numbers printed on them mean, or the specs that you can see on their spec sheets, and how to choose the best one for your next project and treat it with the care that it needs. LiPo batteries are called lithium polymer batteries for longer version of the name, and that's because they have a solid or gel polymer electrolyte. Every single battery is made up of three main components: a cathode, an anode, and an electrolyte that allows the charges to move between them. That's how they're able to produce power. If you push energy into the battery, it can recharge, and if you allow it to discharge through a device, it can power that device. Your phone, your laptop, maybe even your electric car all use pretty similar lithium batteries to what we have here. But this is obviously quite a bit bigger than what you might find in your smartphone. Now, when you're looking at smartphones, you might see that some of them have a 3000 milliamp hour battery, some of them have a 5000 milliamp hour battery, and these batteries are no different. This one is a 300 milliamp hour battery, and this one is a 5000 milliamp hour battery. There are three different numbers that are printed on this that are really important for figuring out what is the best thing to use for your next robot or project. Number one is that capacity number, 5000 milliamp hours. Number two is the cell count. In this case, we've got a 3-cell battery, 11.1 volts, because each cell in a LiPo battery is exactly 3.7 volts at 50% state of charge, also known as the nominal charge. And lastly, we've got 50C. This is the discharge rating for the battery. Sometimes these can be a bit misleading, and I'll talk about that shortly. But the important thing to note is that it's some indication of how much current you can pull out of the battery at one time. It's supposed to be 50 times the capacity in amp hours. So for a 5000 milliamp hour battery, this is a 5 amp hour battery. And that means that in theory, you can discharge this 5 times 50C or 250 amps. Now, I don't think that's realistic for this battery, but that's what the manufacturer wants you to believe. The cell count of the battery determines its voltage. A 2-cell battery would have a 7.4 volt nominal, 3 cells is 11.1 volts nominal, 4 cells is 14.8 volts nominal. Now, there is another type of lithium polymer battery known as LiHV or lithium high voltage. These can charge up to 4.35 volts per cell and have a nominal of 3.85 volts. So the LiHV batteries give you a little bit more energy for the same size, and they're only a little bit more expensive, so they tend to be what a lot of combat bot builders are leaning towards these days. But if you're not trying to make a combat robot or a drone, you might not need the extra energy density that you get, and you might be able to save a little bit of money by going with a standard LiPo. All right, let's talk about that capacity number, shall we? What exactly does 5000 milliamp hours actually mean? Well, it's quite simple. It means that if you draw 5 amps from this battery, then it should drain in 1 hour. And if you draw 1 amp from this battery, it should drain in 5 hours. If you want to draw 10 amps from this battery, it would drain in half an hour. So pretty straightforward math there. The milliamp hours of the battery is just a measure of its energy storage. There's another number you can see here, 55.5 watt hours, or WH. Watt hours is simply amp hours times voltage. So in this case, it's a 3-cell battery, so 11.1 times 5 equals 55.5 watt hours. That is the complete amount of energy storage of this battery. So that's why a battery like this is so much bigger and heavier than a 5000 milliamp hour battery in a smartphone, because this has 3 times the energy since it's a 3-cell battery. So how does that help you figure out what size of a battery you need for your next robot or project? Well, if you measure the amount of current draw that your project will have or your bot will have, or you have a really good way of predicting it, and figure out what the average current draw will be and the length of time you need it to happen for, it's pretty easy to do the math. For instance, for a combat robot, we are trying to get the robot to last for a 3-minute long fight. 3 minutes divided by 60 minutes per hour gives you 0.05 hours. So if we take 17 amps of current, for instance, and multiply it by 0.05 hours, we get 0.85 amp hours, telling us this battery is exactly the size that we would need for 17 amps for 3 minutes. Pretty straightforward. The hard part is then figuring out actually how much current your robot will need, and for that you might have to do some experimental testing, and I'll talk about how I do that later on in this video. The last number that's important on here is, like I said, that C rating. And these C ratings are often not so much to be trusted, but it's a good idea to understand what they actually represent, because even if you assume that the manufacturer is lying and the real C rating is half of what's printed, at least that gives you something to go off of. So in this case, this is a 50C battery. That means it should be able to supply 50 times its capacity in amp hours as a continuous current draw, which in this case would be 50 times 5, or 250 amps. There's no way this battery can actually cope with 250 amps, especially not continuously. It might be able to do it for like a tenth of a second, but certainly not continuously. There's no standardized test to verify what those numbers actually mean though, and so most manufacturers just lie and print a big number on there to make themselves look better than their competing other brands. So if you look at batteries within a brand, you probably can get some useful idea of, this 80C battery isn't going to deliver as much current for its capacity as this 120C battery, but it's generally not a great idea to take those numbers at face value. And if you're working in the small niche field of combat robots, there's a lot of helpful people out there like myself, and the best thing you can often do is just say, hey, I'm building such and such type of robot. Has anyone else built a robot like this before? What battery were you using? And more than often, you'll find that people are happy to share. That is frequently the best way to really pick a battery for your project if somebody else has done a similar project before. And if you're not making a combat robot and doing a more general robotics project, you probably don't need anywhere close to the burst current that these batteries are claiming, and you don't really have to worry about the C rating at all anyway. The next best thing that you can do is to buy a power meter. You can buy these RC power meters like the WM150, or even cheaper options on Amazon for anywhere from like $10 to $35-ish, maybe if you look on AliExpress. And those are by far, in my opinion, the best way to figure out how much current your robot actually needs. Simply plug a battery into one side, plug your robot into the other, and measure the current going through the thing. And if you're trying to optimize every gram out of your project, you're probably going to want to know exactly how many milliamp hours you really need. Now, within the world of combat robots, most people are building scary spinning weapon bots, and I am a huge proponent of properly and safely testing your robots. You should never, ever, ever test a spinning weapon bot out in the open with maintaining line of sight. Build a test box, and if you can't do that, then prop your phone up on something or put it on a tripod and hide behind a wall whenever you spin up that weapon. The weapon's going to draw way more current than anything else that your robot needs. The drivetrain is going to be a tiny percentage of how much energy that the weapon's going to use for 3 minutes. So even just testing the weapon clamped in a vise or on a bench is going to give you a pretty good idea of how much power that you truly need. Speaking of how much power you need and making a good investment on your equipment, let's talk about battery chargers. Smart battery LiPo chargers, also known as balance chargers, are your friend when using these things. That is going to be the biggest difference between having a fire and not, is properly choosing and using your charger. Every single proper smart charger has 3 really useful functions. The ability to charge your battery while balancing the individual cell voltages, the ability to change the amount of current that you're putting into the battery at once so that you don't exceed its charge C rating, and the ability to storage charge the battery when you are done using it for a few weeks at a time. The storage charge function simply brings the battery down pretty much to its nominal voltage, or maybe 60% state of charge. And this is really good for storing your batteries for months or even potentially years at a time when they're just going to be sitting in a big bin, like the many, many batteries that I have that I don't need every single day. Every time I go to a competition, I charge all my batteries in the days leading up to it, and then I discharge all of them to storage in the couple weeks afterwards. It doesn't have to happen immediately, but I'd say at most leave your batteries fully charged or fully discharged for at most 1 or 2 weeks. This is the best way to take care of them long term, and it will by far be the safest way to store them. Another thing to keep in mind, and a mistake that I have definitely made in the past, is never ever leave a battery charging unattended. You never know what can go wrong. Back where I was growing up, my brother was working on a robot project and he put a battery on charge and then left to go to a friend's house. And his charger malfunctioned, the battery overcharged and blew up, and we had to get the fire department called in to put out a huge fire, burning a hole in the carpet of his bedroom. Thankfully, it didn't get any worse than that, but it certainly could have. And myself, I had a very similar issue. I accidentally set a charger to the wrong setting at one point. I set it to a 4-cell voltage instead of 3-cell, and the charger I was using was a slightly crappier one that didn't automatically detect it. It overcharged the battery blew up, and I had to go and take care of it myself. Thankfully, that was a much less serious fire because it was pretty self-contained, so I was able to handle it myself without the fire department being called first. But knowing what to do in that situation is important, so let's talk about that too. If a lithium polymer battery does catch fire, lithium fires are self-oxygenating. This means that smothering the fire with water will not actually put it out, but it will cool it down, which isn't always a terrible thing. However, having boiling water thrown in your face is. So generally speaking, you want to put your batteries in a sand bucket. That's what most combat robot events have, because sand does not boil or explode when it gets hot. Now, like I said, you want to choose a charger that lets you adjust the current, but what do you adjust the current to? Well, generally I'd say you charge at most 2C at a competition, and when you have the time to spare, I just charge at 1C, which means it'll take a full hour. So an 850 milliamp hour battery, you charge at 0.85 amps. A 1 amp hour battery, you charge at 1 amp. If you're at a competition, you can double that, and it'll charge in half an hour instead of 1 hour. And of course, if the battery isn't at 0%, it'll take a lot less than that full time anyway. So most of the time, your turnaround between fights of only 20 minutes at NHRL, for instance, is still plenty of time to charge your battery. But I always recommend keeping a second one on hand so that you don't have to be pushing your charger and your battery that hard between every single fight. So yeah, charging at 1 to 2C max, making sure you're always using the balanced charge setting if your charger has it, or at least making sure the balance plug is connected to your charger every time you charge if it isn't using a balanced charge setting. But a lot of chargers have a fast charge mode and then a balanced charge mode. I would strongly recommend just always using the balanced charge mode and connecting that balanced connector, since not only will that make sure your cells are balanced, but it'll also usually automatically detect if you have the wrong number of cells plugged in. So if you tried to charge a 3-cell battery on the 6-cell setting, because the last battery you charged was 6S, it will not just immediately blow up. It'll instead warn you about it and might just not even let you start the process to begin with. If your battery is puffy, if your battery has a cell that's below 3 volts, or otherwise just seems really, really hot and kind of sketchy or gets crushed or anything, it's not worth trying to save it. Never attempt to do this because this just really increases the chance of a fire. You should just throw it in a sand bucket if you're at a competition, or if you're home, you can slowly and safely discharge it in one of a few different ways. Some LiPo balance chargers will have a discharge setting that lets it go to 0 volts, but usually they will cap it at like 3.6 or 3.3. The best thing to do, in my opinion, is to get like a small brushed DC motor or LED or some other resistive load that's high enough resistance that it'll draw less than an amp of current continuously, and just plug that into the battery and leave it for like 2 days outside where it can't hurt anybody if something goes wrong. That will discharge it completely to 0 volts. After that point, you could even stab a knife through the battery and nothing will happen because it's no longer energized, and you could throw it in the trash like normal or bring it to a batteries plus bulbs store for recycling, which honestly you could probably do with a storage charged battery too, but I just think it's safer to discharge it all the way first. Another thing that you can do to prevent damaging your batteries is using one of these little voltage alarm checker things. These guys are great. You can plug them into a battery and leave them plugged in while you're testing your bot or project, and when it drops below 3.3 volts per cell, the alarm will go off, letting you know that it's time to stop without overdrawing your battery and potentially killing it, which I've definitely done quite a few times in bots where I couldn't fit one of those inside of them while testing. You gotta be careful about stuff like that, but the voltage alarms make it easier. They also are really handy if you're in the pits between fights and you've got 2 batteries next to you and you don't know which one's charged and which one's discharged, and you just need to really quickly plug something into the battery to see what voltage all the cells are at and check if it's all good. And they're also helpful for diagnosing if you plug your 4-cell battery into your charger and it reads as a 3-cell, what's going on? Well, it might be that one of the cells got disconnected internally, and this will be able to tell you that because it'll show like 0 volts or like 1 volt for that cell. So that'll also tell you if your battery is irreparably damaged. These things are like $2, kind of a no-brainer to get them in my opinion. Now, let's go over a few more advanced tips and tricks. First off, what if you can't find a battery that's just the right size and shape and capacity and voltage for what you need? Well, you might be able to combine 2 of them. If you combine 2 batteries in one of 2 different ways, you can get 2 different outcomes. You can either wire them in series. If you take 2 4-cell batteries and wire them in series, it's the same as just making an 8-cell battery, which has double the voltage of the 2 4-cells individually. Or you can wire them in parallel. When you wire batteries in parallel, this is creating, say, a 4S2P pack instead of a 8S1P. So a 4S2P pack means that you've got 2 4S series cell packs wired together such that they become essentially one 4S pack with double the capacity and double the C rating or discharge rating. So in other words, if you have 2 800 milliamp hour batteries and you wire them in parallel, it becomes a single 1600 milliamp hour battery. But all the other specs, like the voltage and the cell count, are essentially the same. Just the C rating could also potentially be doubled, as long as your wires can support the extra discharge current and your robot's actually going to need it, that is. Another thing you can do is wiring batteries in series, because most of the cheaper smart chargers out there only support up to 6-cell batteries. So if you want to run a system on 12S or 10S or 8S, you could wire 2 6, 5, or 4-cell batteries in series, and then you can just unplug them and charge them individually with a regular LiPo charger without having to buy an expensive fancy one that can handle a super high voltage battery. Most of the time, you're wiring batteries in parallel so that you can get more capacity, but without having the robot battery be like super long. So like obviously this 5,000 milliamp hour battery is super long, but if you wanted a super fat and skinny pack, you could just like wire a bunch of these in parallel and get a similar effect. I sell little PCBs on my website that make it really easy to wire batteries in either of these configurations with XT30 connectors on them. And you can also buy those connectors from my website, or you can get XT30s on Amazon, for instance, or eBay, or any number of other sites. And that gets us to the topic of connectors. Not all batteries have the same connector. This one has an XT60 on it. These all have like XT30s on them. And usually a battery will come with one of those 2 connectors if it's at the size for a 3-pound bot or below. A 12-pound or 30-pound bot size battery might come with an XT60 or even an XT90, or in some rare cases a different connector. The different sizes of wires and different sizes of connectors that your battery uses are usually a good indication of what you should use in the rest of your robot. But I would say for 3-pound robots especially, an XT30 is going to be fine 99.9% of the time. Even if your battery comes with an XT60, you can probably cut it off and solder on an XT30 if you really want to. But also, when re-terminating a battery, you have to be super careful, because if you ever short circuit the 2 leads of the battery together, it could weld the leads together with the amount of current that's instantaneously generated and then get super hot and blow up. So when you are re-terminating a battery, you should only ever cut 1 lead at a time. Then you should solder that lead to the new connector, and only then, after insulating that connection, do you cut the other lead. Or if you must cut both at once, you cut one, wrap it in electrical tape, then cut the other. You can also extend the wires if you need to in a similar fashion. Just be super careful to never leave both battery leads exposed copper at the same time, because you do not want to have a situation where it short circuits. Now, if you're looking to make a custom robot project or anything else that might need battery power, there's a pretty good chance that somewhere in that robot is going to be one of these, a PCB. And you can get custom PCBs made by today's video sponsor, PCBWay. PCBWay is an awesome one-stop shop for 3D printing with industrial machines and materials, CNC machining, injection molding, sheet metal fabrication, and of course, PCB fabrication as well as PCB assembly. So they can produce boards like these that make your next robot project super simple and easy. Definitely check them out at the link below. They do awesome work, and they've made all sorts of awesome stuff for me in past robot projects. They've made some awesome stuff for me in the past, like this 7075 aluminum machined carriage bracket for a punching spinner comet robot that I built. And they've machined the entire chassis for the 3-pound robot that's the orange one on the shelf behind me as well. as many other things for past projects. Check them out at the link down below to get $5 off of your first order. All right, I think that covers pretty much everything that I had to say about batteries today. If you have any other questions about any other things to do with batteries, leave them in the comments below. And also let me know if you'd like for me to make a follow-up video talking about how to size all the other components in your robot. I made one many years ago that I can link down below and maybe have a card too above, where I talked about how to not blow up the rest of your robot by choosing the wrong size speed controllers and motors and such. But it's definitely a topic that could always be revisited because that video is a few years old now, and I've started selling a bunch more custom parts that, you know, I have matching speed controllers for that makes things a little bit easier than they were back then. So yeah, if you want to see that video, sound off in the comments. If you like this video, click like. And as always, thank you so much for watching, and subscribe if you want to see more videos like this in the future. Bye.